Good afternoon. Today we are going to see some problems that is of simple stresses and strains which were asked in previous question papers of Pune University. Now this question was asked in May 2015. So a compound bar ABC 1.5 meter long is made up of two bars AB of aluminum and BC of steel having cross-sectional area of steel, half of aluminum. So if we will write given data, so we have given A steel that is equal to A aluminum by 2. Then the rod is fixed at A and subjected to an axial pull of 200 kilonewton. So P is given 200 kilonewton. At end C, if the elongation of both material is equal, so this is given delta aluminum equal to delta steel. Find the lengths of each part. E steel given. So E for steel is given 200 into 10 raised to 3 Newton per mm square. And E for aluminum is given 1/3 of ES. So we can say that is 200 into 10 raised to 3 divided by 3. And so this data is given. We have given A of aluminum plus A of steel that is equal to 1500 millimeter. Now we will start to solve this. So it is given two bars or composite bar, aluminum and steel, and one end is fixed. If I will draw the diagram, so we are been like this. So this is of aluminum, and then we have of steel. We do not know whose length is more or whose length is less. So we have given this as A, B, C, and this is given 200 kilonewton. So now obviously if you will see, we will get reaction at A 300 kilonewton and towards left, because it is very clear we have summation Fx equal to 0. And if we will draw these two diagrams separately, then in both we are going to get 200 kilonewton tensile. So we have here 200 kilonewton tensile. Then we have tensile, so towards right. And then we have for this aluminum, so we have again 200 on this side, 200 kilonewton, and we have 200 kilonewton on this side. So how this comes, that already we have explained in the class. Now let us, we have A of aluminum equal to A, then we will get A of steel is A by 2. If I will say this length is L1, this length is L2, then we have, this is L1, and this value we will get it as 1500 minus L1. Because total we have 1500. Now E for aluminum is given. E for aluminum 200 into 10 raised to 3 upon 3, and that is Newton per mm square. And E for steel, this is given as 200 into 10 raised to 3 Newton per mm square. And now delta L is given same. So delta L of aluminum is given, delta L of steel. Now we have formula for delta L, PL upon AE for aluminum, and that is equal to PL upon AE for steel. Now we have P same for both, so I will cancel this P. And now we have L for aluminum is L1, area we have for aluminum A, area for, sorry, E for aluminum we have 200 into 10 raised to 3 upon 3. So we have mentioned over here, which is equal to, we have this value 1500 minus 11 divided by, we have A, that is A by 2 into 200 into 10 raised to 3, which is E for steel. So this 200 into 10 raised to 3 gets cancelled. This A gets cancelled. And we will get it as 3L1 equal to 2 into 1500 minus L1. And if you solve this, we will get it as 3000 minus 2L1. Now, if we will rearrange the term, we will get 5L1 equal to 1500. And therefore, L1 we have, so sorry, this is 3000. And therefore, L1 we have 3000 upon 5. And that is equal to 600 millimeter. And therefore, length of aluminum bar, so we will have length of aluminum bar, length of aluminum bar is 600, and therefore length of steel bar, so 1500 minus 600, which is 900 millimeter. So likewise, we have to find the values, whatever given data, you have to write it very clearly and then start to solve the problem. Then we have another problem, a steel bar 2 meter long is at 30 degrees centigrade. The temperature of the rod is increased by, it is not mentioned 2, it is mentioned by, means this is value of T, 150 degree. Now we have to find free expansion of the rod. So now we will write given data. So we have given, so we will go one by one. So we have given data. We have given L, that is equal to 2000 millimeter. Then we have given temperature T 150 degree by, it is increased by 150 degrees centigrade, increase to not given. And we have to find free expansion. So we have first part, free expansion. And we have simple formula, that is L alpha T. Now E is given 210 GPa. Alpha is given 12 into 10 raised to minus 6. And D is given 16. So we have alpha 12 into 10 raised to minus 6 per degree centigrade. Then we have given E to 10 into 10 raised to 3 MPa. And D is given, that is 16 millimeters. Now first we have simple delta L, free expansion is L alpha T. We have value of L 2000. Alpha we have 12 into 10 raised to minus 6. In T we have 150. And if we will solve this, we will multiply this, we will get value of delta L, that is equal to 3.6 millimeters. Now B, we have question, that is second temperature stress produced if it is prevented from expansion. So prevented from expansion. Prevented from expansion. So we have to find the stress. And then we have formula sigma equal to alpha TE. Alpha we have 12 into 10 raised to minus 6. T we have 150 and E we have 200 into 10 raised to 3. So here we can write delta L 3.6 millimeters. So should be clear that answers in blocks, and therefore if we will solve this, we will have value of sigma, and that is equal to, so we will just calculate it, 12 into 10 raised to minus 6 into 150 into 200 to the power 3. So 360 MPa. 360 Newton per mm square. So 12 into 10 raised to minus 6 into 150 into 200, sorry, 210. We have value of E, that is 210. So this comes to 10. So it is not 200. So 210 to the power 3, it is 378. So I will just change it. 378. So this is 378 Newton per mm square. In exam also we are going to commit this mistake. So sometimes they have given 205 to 200. So we are going to make that mistake. So be very careful with this. C, they have given stress produced if 2.5 mm expansion is permitted. Assume supports are unyielding. So 2.5 mm expansion is permitted. Means now what is delta L? So we have delta L equal to delta L R load equal to 2.5 millimeters. Now we have to find out how much temperature is required for this. So delta L equal to L alpha T. Now delta L is 2.5. L is 2000. Alpha is 12 into 10 raised to minus 6 into T. And by solving this, we will get value of T, that is 2.5 divided by 2000 divided by 12 to the power minus 6. It comes 104.17 degrees centigrade. Now it is heated by 150. So we have to find T1 equal to 150 minus 104.17. So from 104.17 to 150, stresses will be produced. And so we have this value 45.83. And for this 45.83 degrees centigrade, stress will develop, and therefore we can write formula, that is sigma equal to alpha TE. And now we have 12 into 10 raised to minus 6. T we have 45.83 and E we have 210 into 10 raised to 3. And if we calculate this, 12 to the power minus 6 into 45.83 to 10 to the power 3. So it comes 115.49. So it is 115.49 MPa. Just check the calculation. Sometimes there may be some mistake in calculating the value. So I am calculating actually double, but maybe sometimes some value taken. So we have, this will be third answer. Now we will go one more problem. That is, the bar is tested in universal testing machine. It is observed that total expansion is given 0.285, determine Young's modulus of the bar material. Now you can see we have this two bars same. So if you will see, we have this as first bar, that is also 25 millimeter. We have third bar also 25. Their lengths are also same 160. Load also we have P at ends. So in each bar, we are going to get same value, that is P. So you need not require to calculate when we are whole bar, and if load is acting at ends, then we have same value for all. And therefore we can simply solve this very easily. So given data we can write. So we have given D, that is 25 millimeters. D1 I will say. And therefore we will get value of A1, that is equal to A1 equal to 490.87. 490.87 millimeters square. And then D2 we have, that is equal to 20 millimeters. And area we have 314.16 millimeters square. Now L1 we have, so if we will see L1 160 and L2 240. L1 160 and L2 we have 240. 240 millimeters. E we have to find, and delta L overall is 0.285 millimeters. So now we will solve this. We have simple formula, delta L equal to delta L1 plus delta L2 plus delta L3. As data for 1 and 3 are same, so I can write it as 2 delta L1 plus delta L2. And then we will put the values, that is 0.285. Now what is value delta L? So we have delta L equal to PL upon AE. Now I will write 2 into P1L1 upon A1 even plus P2L2 upon A2 E2. Now P and E is the same, so we can go for 0.285. P is given 40 into 10 raised to 3. E we have to find out, and then in bracket we have 2 into L1 is 160 and A1, that is 25 mm. So we have 490.87 plus L2 we have 240 and A2 we have 314.16. And then if we will solve this, and from this we will get value of E, that is equal to 198.72 into 10 raised to 3 Newton per mm square, and that is E equal to 198.72 GPa. Now you just calculate this and check the answer is correct or not. I will once calculate. I have calculated 320 divided by 490.87 plus 240 divided by 314.16 multiply by 40 to the power 3 x inverse into divided by 0.285. Just I will calculate 320 divided by 490.87 plus 240 divided by 314.16 multiply by 40 to the power 3 and divided by 0.285. So yes, I have 198.72. So this is all about first three problems. So remaining part we will see in the next lecture. So my WhatsApp number, if you will see, so 70388 31674. So any doubt you have, then you can have message on this number. So now we will stop here only. Thank you.